Newly installed cameras capturing an eruption from the Black Diamond Pool at Yellowstone National Park on Saturday.
Yellowstone is acting wrong. Surprise blasts of boiling mud. New holes where ground was solid yesterday, and instruments showing one side rising while another subtly sinks. Add a newly mapped magma cap that changes the risk math, and you get a park that feels like it's rewriting its own rules. Is this the start of a transformation, or just Yellowstone reminding us who's in charge? The first tier. Yellowstone felt ordinary until the day the ground spoke. A sharp crack leapt across a meadow near a steaming runoff channel, followed by a low, rolling thud that people felt in their knees more than they heard with their ears. When dust cleared, a fresh fissure lay open, about 100 feet long, edges lifted and ragged like torn fabric. Rangers set ropes. Phones filmed. Headlines did what headlines do, declaring the park was splitting in two. Scientists did what scientists do: kneel, measure, sample, and argue quietly, urgently, over the meaning of a brand new wound. By sundown, two truths held. First, the gash was shallow, a skin wound by geologic standards, not a trench announcing catastrophe. Second, instruments nearby were calmer than the photos implied. No stampede of earthquakes, no explosive gas spike, just a rearranged patch inside a famously restless machine. Still, calm is not simple here. Beneath every postcard pool, boiling water. CO2, H2S, and mineral-rich fluids test new routes through old fractures. When a seam gives, Yellowstone updates its map. First pass readings told that story. Hydrothermal plumbing had found an exit, redirecting heat and water into cracks nobody mapped yesterday. Yellowstone's crust is a patchwork quilt of strong blocks, weak seams, mineral glues, and healed scars. Sometimes a healed scar relents all at once, and a line becomes a gap. That doesn't mean a continent is snapping, but it does mean the surface can reorganize faster than our stories keep up. That evening, the printer spat graphs. Subtle uplift within a mile, subtle settling a few miles east, the kind of contradiction that ruins tidy metaphors. You could stand with one boot on rising ground and the other on sinking ground and never know it, until a boardwalk detours and a familiar overlook vanishes behind fresh rope. So, is this a theatrical tear, or an opening whisper from deeper forces preparing their next sentence? Mirrors in motion. For years, people described Yellowstone like a single breathing bowl. The caldera rises, the caldera falls, the caldera exhales through geysers. Lately, the breath feels out of sync. GPS pins, those small, unsleeping witnesses bolted into bedrock, show gentle uplift to the west and subtle subsidence to the east. A tidy bowl it is not. It's a quilt, and the quilt is tugging in opposite directions. The new pattern complicates the old story. Uplift hints at pressure below, sometimes magma adding heat to rock, sometimes hot water charging into pores, sometimes gases inflating shallow spaces like wobbly balloons. Subsidence can mean fluids draining, fractures unclogging, or roofs sagging as voids relax. Put them together, and the picture turns asymmetrical. Pressure builds here, while pressure bleeds there. One side breathes in, while the other breathes out. Satellites corroborate what ground stations record. Millimeters matter. In a place this sensitive, a few millimeters of rise can redirect a hydrothermal vein. A few of fall can relax stresses along a fault. This divergent motion isn't a cinematic rip. It's moving geometry. Where uplift and subsidence meet, strains concentrate. Strain hunts weaknesses. Weaknesses invite change. Scientists test models that mix magma dynamics with hydrothermal hydraulics. In some runs, ascending heat thins rock on the west side, while old pathways drain the east. In others, gas pockets accumulate beneath tight caps, while neighboring caps leak, like two pressure cookers with very different valves. No model is perfect. The data keep editing the script. If the park's halves are moving like misaligned mirrors, where does the tension focus? Quietly along a seam we haven't noticed yet, or loudly at the next place the crust chooses to blink? Unruly water. People expect volcanic drama to come from magma, but Yellowstone's flashiest surprises often belong to water. Hydrothermal explosions are less about lava and more about plumbing. Trapped liquids superheat, a brittle lid fails, and energy stored in hot water releases as flying mud, fractured rock, and sudden steam. The result looks like violence. The cause is usually a clogged pipe. When that 100-foot fissure appeared, rangers also logged sudden mud bursts, where pools had simmered quietly for years. A basin that rarely changed in a month changed in a morning. In places nicknamed Black Diamond and near Norris, small hydrothermal blasts hurled water, clay, and stones skyward. None were cataclysmic, but each rewrote a corner of the surface. New vent here, fresh crust there. Off-limits sign where yesterday's trail felt safe. Under the boardwalks, pressure migrates through fractured rock like whispers through walls. Silica cements some cracks, sealing them. Heat expands fluids, stressing those seals. Minerals precipitate, narrowing throats. A fishbone lattice of pores accepts or rejects flow minute by minute. When one valve blows, pressure elsewhere relaxes, until it doesn't. Then a neighboring valve takes its turn. The choreography is messy, and that mess is normal here. A park can be busy without being escalating. Still, patterns matter. Clustered explosions, temperature jumps in certain pools, sudden drying in others, snowfall melting faster on slopes that never steamed before. The network watches for these alignments because aligned anomalies sometimes precede bigger surprises. If hydrothermal behavior is the visible punctuation of deeper processes, what reads like a scattered series of commas today, short bursts, detours, hiss, might tomorrow become a semicolon, a longer pause, a larger rearrangement. Which valve is straining in silence right now, and which brittle lid will write the next sentence? The listening net. Rumor runs faster than science, but Yellowstone's monitoring network is built to keep rumor honest. Seismometers count the tiniest quakes. Infrasound ears listen below human hearing. GPS pins catch hair-thin ground shifts. Gas sensors sniff carbon dioxide and sulfur. Thermal cameras see heat where eyes see fog. Drones map changes the way a copier scans a page. The result is not drama. It's a moving, layered portrait. On any given night, dozens of instruments plot lines that would look boring to anyone not paid to stare at them. Boring lines are the victory lap. They mean the system is talking in its usual voice. But lately, the voice has a rasp. Some stations tick higher, while others sag. A cluster of microquakes migrates west to east, like a whisper changing rooms. A vent warms, then cools, while a nearby pool does the reverse. Nothing screams, everything hints. Those hints drive field days. Fly the drone, swap a battery, relevel a tilt meter, purge a sampler, tighten a bolt that winter worked loose. The goal is continuity. Miss a week, and you can miss the stitch that links two benign events into a pattern worth fussing over. Catch it, and you can nudge a trail closure forward by a day. Move a sign 5 yards. Shift a crowd off a crust that will not hold them tomorrow. People imagine scientists predicting, In reality, they listen and reframe. Today's confidence is a sentence full of ifs. If gas stays steady, if uplift slows, if quakes do not cluster, if heat redistributes. Each if buys time, and time reduces risk. If the network is our stethoscope on Earth's largest hot water bottle, what quiet murmur will become the first unmistakable clearing of the throat? Beyond splitting. Splitting in two is a headline. Complex porous flow coupling under heterogeneous stress is the truth. We hunger for clean metaphors because they make fear legible. The ground is either fine or failing. The volcano is either asleep or awake. Yellowstone rejects those binaries. It is a restless plumbing system heated from below, carved by ice, glued by minerals, cracked by quakes, and perpetually edited by hot water searching for exits. Opposing motions do not require a grand rip from space. They can arise from subtle shifts in how fluids partition between rock volumes. One area inflates as another deflates, like a pair of lungs breathing out of phase. A fissure can be dramatic at the surface and utterly local at depth. A new vent can be a relocated old one. What looks like a line on a photograph is often a knot of small stories told at once. This does not mean nothing to see here. It means what we see is a symptom, not the disease. The hard work is to infer process from pattern without pretending certainty. Does a west side uplift reflect gas accumulating beneath a stiff cap? Does east side settling mark a drained reservoir? Did silica seal one conduit, forcing heat to detour through shallower rock? Or are we watching the long tail of prior activity finally move the needle? Better questions, better safety. If strain is migrating, where is the next brittle piece likely to fail? If heat is rerouting, where is crust thinnest? If the system is not one bowl, but a linked mesh, which meshes are tightening and which are loosening? Instead of asking, is Yellowstone tearing apart, the more useful challenge is this: which small truths add up to the next change we'll have to live with? The magma cap. Beneath the park's bright pools and dark pines lies a layered engine, a deeper mush of partially molten rock feeding a shallower zone of hot, volatile-rich material, overlain by fractured crust that doubles as heat exchanger and bomb squad. Between melt and crust sits a leaky lid, call it a cap, where gases accumulate, dissolve, and escape through countless small pathways. When those pathways are open, pressure bleeds quietly. When they narrow, stored energy seeks new weaknesses. Imaging and geochemical studies point to a cap that is venting, safer than sealing, but never safe. CO2 finds daylight in some basins, sulfur pulses elsewhere. Heat flux is not uniform, and that unevenness maps onto the uplift-subsidence puzzle. Think of two neighborhoods sharing one water main. A clog in one sends flow into the other. Pressure readings differ street by street. If the cap stays weepy, surface drama may stay scattered. Local blasts, new vents, boardwalk detours. If parts of the cap stiffen, minerals sealing pores, silica lining throats, fluids may pond beneath tighter roofs, inflating shallow rock and sharpening strains along faults. The system has many safety valves. None are perfect. It also has memory. A sealed path today can become tomorrow's pre-weakened rupture line. Engineers would love a dashboard, one dial for melt, one for gas, one for water. Yellowstone gives us mosaics. Gas ratios here, seismic velocities there, tilt everywhere, temperatures always drifting. The art is to assemble them into a sketch that buys both time and proportion. If the lid is hissing instead of humming, and if some vents whistle while others fall quiet, Are we watching pressure distribute into a safer patchwork or concentrate into a narrower, more consequential problem? Stone, steam, habit. Yellowstone's rhythms rewrite human habits. Heat opens cracks. Minerals reseal. Pressure hunts exits. The map updates. And people adapt, usually the day after the ground does. A familiar loop closes for your safety. A beloved angle on a geyser disappears behind a rope. A new vent, small but convincing, turns a shortcut into a no-go. The park is a laboratory with corridors that move. Rock remembers every insult. A freeze-thaw winter, prees open a seam that summer's silica later glues. An earthquake from years ago left a fracture that today's hot water reoccupies with gusto. Hydrothermal fluids deposit iron in one artery, quartz in another, clays over there. Each mineral choice changes how stiff, slick, or permeable a pathway becomes. Multiply that by thousands of pathways, and you understand why yesterday's safe crust is not a guarantee. Managers play chess against a board that redraws itself. They study thermal imagery, gas logs, and microquake maps. Then drag a sawhorse 3 feet left and call it prevention. It works because most visitors accept the contract. Awe in exchange for obedience. The plan only fails when curiosity leaps a rail or when novelty outruns the signs. The smarter habit is humility. The ground does not negotiate. In a place where a quiet patch can boil by evening, where the snow melts fastest above tomorrow's hole, the safest move is to let the scientists and rangers be the impatient ones on your behalf. If habits must change, as the ground redraws the map, what are the subsurface signals that tell us when to change? Quakes you don't feel. Yellowstone hums with earthquakes, the kind you don't notice unless you sleep on granite or stare at seismograms for a living. Swarms map fluids moving, faults adjusting, and rock flushing stresses the way a body clears lactic acid after a sprint. Most are shallow and small. They work like maintenance cycles for a machine that refuses to stop. This year, the hum grew a fraction louder, particularly beneath uplift zones. A handful of deeper events stitched beneath the subsiding side. One stronger jolt rattled windows without rewriting forecasts. It was a paragraph break, not a plot twist. More interesting were the patterns. A swarm that migrated a kilometer in a day, a cluster that pulsed every few hours, a lull where noise usually lives. The ensemble suggested plumbing tuning itself, not magma marching. Seismologists are professional skeptics married to pattern recognition. They know that hydrothermal systems can masquerade as magmatic signals, that ice quakes talk loudly in spring, and that station outages turn truth into stutter. They also know this: in a place where strain is partitioned unevenly, small faults can link, and linked faults change the game. We don't need catastrophe to get hurt here. We need a sidewalk to sag into a boiling vein. Earthquakes, even tiny ones, can open that vein. Most days they relieve pressure. Some days they realign it. The difference is subtle until it isn't. So, if the ground's gossip is 1,000 whispers rather than one shout, are we listening for the right thing rather than chasing the single bang we fear? Risk we live with. Super eruption fantasies are cinematic bait. Scalds, collapses, and toxic gases are the real risks you can meet by lunchtime. Yellowstone's hazard ledger is practical. Thin crust masquerading as a path, runoff channels flashing hot, sudden vents punching through soil, geyser water raining where curiosity wandered too close. Scale your fear to the physics at hand, and you stay both awed and intact. Proportion is protection. Heed closures even when the rope feels silly. Read wind as a safety tool. Don't stand downwind of steam. Trust your nose. Sulfur is a message. Keep kids on planks, because planks are the difference between geothermal research and emergency medicine. And if a basin's rhythm feels off, give it the gift of distance. The same instincts that keep wranglers out of bad river crossings apply here. For locals, preparedness looks like plans. Where to go if a road shuts, how to read advisories, which valleys flood when snowmelt meets warm ground. For managers, it looks like rehearsals, radios charged, cones stacked, detours tested. For scientists, it looks like humility in public. Here's what we know, here's what we don't, and here's what we're watching next. The park is not a bomb, it's a boiler. Boilers are safest when their gauges are watched, their relief valves respected, and their operators allowed to be boring perfectionists. Can we hold awe and caution in the same breath? Or do we insist on choosing spectacle over the simple habits that keep us from becoming part of the cautionary tale? Lessons, not legends. Every surprise becomes calibration. A fissure edits the hazard map. A swarm refines a stress model. A pop-up vent teaches the gas network what normal no longer means. The feedback loop never stops. Field notes feed the lab feeds the briefings feed the next day's road cones. Yellowstone is a classroom that grades in real time. Humility is the curriculum. The system refuses neat narratives, but it rewards patience. In one season, you can watch an anomaly swell into concern, fade into trivia, then reappear 2 basins away as context for a better decision. Tourists see spectacle. Crews see signal. Both are true, but only one pays tomorrow's safety bill. Communication is its own kind of mitigation. Clearer signage converts confusion into compliance. Better animations turn fear into understanding. A faster tweet moves 12 people off a crust they shouldn't stand on. When science speaks without swagger, people listen without defensiveness. That is not PR, that is hazard reduction. Legends say Yellowstone is a ticking monster. Lessons say it's a complex patient. Patients need monitoring, compassion, boundaries, and the will to adjust treatment as symptoms evolve. Are we willing to update the story as the ground updates itself, or will we keep trying to cram today's messy truth into yesterday's tidy myth? Busy but behaving. Steam drifts across meadows at dawn. Bison ghost through fog. A raven's wing cuts sulfur air. Instruments tick, not tilt. The magma cap hisses through countless pinholes rather than hoarding pressure. West lifts a little, east settles a little, and life slots itself between those motions the way roots probe cracks in stone. Official status: normal for Yellowstone, which is not the same as ordinary anywhere else. Busy but behaving is not a lullaby. It's a disciplined sentence. It means the machine is working, the gauges are honest, and the operators are neither complacent nor theatrical. It means the park's changes are the scale we plan for. Meters of rope, hours of detour, a handful of sawhorses moved before breakfast. It means our appetite for drama stays in check, while our respect remains maximal. Could that change? Of course. The ground does not owe us continuity. A sealed throat could inflate a roof. A focused swarm could unzip a fault. A steam blast could reroute a morning. But risk is not destiny. Yellowstone's genius is in the dispersion of energy across countless little exits. Our job is to notice when countless becomes concentrated. If Earth revises slowly in front of us, we should revise just as steadily. Keep the sensors honest. Keep the maps current. Keep the public informed without selling fear. The park is not splitting in two. It is showing us again that the most dramatic changes often begin as quiet contradictions. So, as we step off the boardwalk and back into our lives, do we take the hint to move with proportion, to listen longer, and to let complex places stay complex? Yellowstone is busy, but behaving, and that might be the most important headline of all. If you want the next twist the moment it shows up on the instruments, hit subscribe and turn on notifications. Tell me in the comments which sign you would watch first. Share this with someone who still thinks only super eruptions matter. Then stick around for the next deep dive.